that one, physics, looks good. There are no lights. We can't see anything. Add some lights to your scenes. I made sure to make that explicit in my write-up for the next one. Add lights. We need to see what's going on inside. Open other. So close. So, comes down. It's a little lower than the others. I don't think the physics material is on the balls. Sometimes I saw it on the larger shape, but it has to be specifically on that sphere in order for the sphere to be smacking back and forth at the right spot. What else did we get? And it does take a little time to load them all up, back and forth. But this is why I need your whole project. Here we go. Again, getting close. Work on that physics material. Other documents. I think we're on number 6 now. It's cradle. Make the game bigger. I'm not really sure what's happening here with these physics. It is just bouncing away on that left-hand side. And the right balls are sometimes reacting. Something's now they're stuck. Come on.
It's like they're electrically charged.
They might be. I think the hinges might be off in their angle.
Do they have motors? One of them.
Looks like they have motors.
Oh, yeah, those.
They just keep going. It's kind of cool, but not really Newton's cradle. So let's figure out what was going on with these spheres. It's got a rigid body. It's got a hinge joint. Sphere has some cylinders.
Where are the sphere's hinge joints? Can you show a little, like the orange arrows?
Yeah, let's find that. I wish this screen was bigger. It looks like the joints are all in the right spot.
What is their physics material?
Hanging out in the right places. I don't see a physics material. It's missing a physics material. That might be one thing. It's making them bounce strange, but it shouldn't be bouncing that strange. They should just bounce and stick together. So, keep working on that one. Cradle number 7. Don't save my changes. Download. Oh, no. Wrong button.
Do you want to update your software since you're opening this project?
Not right now. Okay. Newtons.
You might drag it.
I don't think this one does anything. There are no scripts. Pieces are there. Things need to be rotated. Something needs. Click on the scene.
This is the game. You're not going to see me drag it.
I could. But that's not exactly what I wanted.
Yeah. Oh. Oh, what?
And I can pick it up and move it. It's attached to that joint.
I know you could even
Boom.
do that in the scene.
Back and forth.
But I didn't know, like... when-
While it's playing, you can mess
while
with the
it's
scene
playing.
as if you are some kind of character in there. Yes. So, the physics looks good, but it is not pulled back directly. There is a rotate script. Somebody decided to add in scripts. C#. We'll learn that here soon. Every update, it transforms, changes the rotation, moves things around. That's good. We'll get to that. Open the project. Let's just see a couple more of these here. We won't go through everything. This cradle. Not bad. It's pretty good. They're hanging down a little bit lower. Sometimes the bounces aren't exactly right, but not bad for that one. Let's open one or two more. We're getting there. Here we go. Where are we? Here's our scene. Whoa. Okay, someone had an amazing time with Unity. They had so much fun. They made water, made their own meshes, fire, flames. But the cradle part doesn't work. Yes, I know. Things are not bouncing correctly. It's awesome to add more things. The basic concepts also need to work. So, interesting.
Guys, our graphics are so good.
Yes, that water is awesome. Those flames are so cool, and we're gonna get there. That is cool. One more. One student went through the process of exporting it to an actual game. I wanted Unity projects so that I could still get in there and look at your joints and look at the hierarchies and put them together. But you can do this. This is what we're eventually going to do, is export games. Export them to the web, or you can export them to a Mac or a Windows or Linux, and then you can play them. You can pick your resolution, see what you want to do with it, and then play your game. So it gives this splash screen. So this was made with a nice free version of Unity. Press the space bar to begin. Someone has an awesome time. But the physics. Oh. Pokemon balls going back and forth, but those physics.
The balls work.
The balls do work. Yes. What is going on with those strings? I don't know. So that shows you some of the diversity, hopefully, of what people did, and shows you still have a little bit more to do to really make that Newton's cradle fit the physics of what it's supposed to be doing. Some pieces are working. You try to add in some awesome, cool new things. Make sure the basics work. So take until Tuesday to work on the Marble Mania and spend time getting the Marble Mania to look like and do the Marble Mania machine stuff. But I want you to start adding in animations, adding in materials, and we'll have a few more things to add in today. Let's see if we can get that new stuff in there. Unity.
When do you want the Newton's cradle stuff reset?
Also by Tuesday. Yeah, I will take them repeated. Yes.
I had a question about like the physics of animation.
Okay.
So when you animate something, like if you have a sphere going around in a circle and whatnot, does it treat that animation like a force being acted on it? Like if there was some physics object in the way of the circle going around and around, would the circle just push that thing out of the way? Would it stop? Would it like slow down? What would happen?
The animation seems to be the highest priority thing.
Okay.
And so it knows it wants to get to this exact position and do this exact thing. If there's things in its way, it will smack them out of the way.
Okay.
And it will continue, and it might jitter a bit and jump out of the way, but then immediately it goes back to its animation to be exactly where it should be.
Okay.
It doesn't say, I'm supposed to spin in a circle, somebody hits me, so I'm going to spin in a circle over here.
Yeah.
It basically says, I'm spinning in a circle, somebody hit me, whoa, okay, I'm back to my circle, and I'm going to do my thing.
So if you wanted to like spin with physics, you would have to like apply forces to it.
Yes. Yes, we have to script and apply different forces and change things. You can either when you start programming, take control of the transform yourself and say, this is exactly the position and rotation and everything that should happen. Or, like you said, apply physics forces. Now there's a force going here, physics engine reacts to that force and makes gravity and makes everything happen along the way. So that second way is the recommended way that they want you to do if you want things to still look like physics. But if you don't care that it looks exactly like physics and you know where things should go, you can take charge of the transform yourself. Yeah?
You know the function called fetch, like a game object's current position? Is that just their vector 3 and you fetch vector 3?
It's a vector 3 in the script. Yeah, and you say just get transform. There's all these wonderful functions that you can call once we get into the coding part. But we're not there yet. We will get to coding soon, but we need to understand what it is, what are these things that we are coding, because we'll be able to code and say, hey, do this animation instead of that animation. Add this material, swap these things out. We need to know what they are. So we're spending time getting familiar just with the language of game design and game creation inside Unity. Okay. So, Unity Project 3. New things that we want to do. Here's our camera. Here's our game. Put this back in. Here's our scene. Let's make a nice cube. Let's make another cube at position 2. Actually, change them so we can just see them nice with our standard camera. Here we go. We have 2 cubes hanging out. They look like they're just in this big blue spot. Back to the camera, we saw how the camera could pick the color of the background. What is that color it's going to be pasting on and refreshing the screen every time. But another option is to add what's called a skybox. Skybox, let's go look up those. Skybox. Skybox is the unfolding of a cube, basically. You are living in your scene, in your world, inside a cube, and there are these 6 walls that are really, really, really far away from you. You can paint those walls every time by using an image that has been unrolled from a cube. The perspective, as if you were inside the cube, this is what the world would look like. Fold this down, fold this up, and then this is wrapping around your 4 dimensions. So skyboxes are available, and people paint skyboxes and let you say, this is my really cool world. It has some nice sky in there. Oh, so beautiful. You can see your skyboxes. You might hear about games like Destiny that comes out and says we have dynamic skyboxes, so the sun might rise a little bit. Most games it just says, here is your flat picture. Let's paste it on there. We know that the weather's not going to change when you're playing this game, or you really don't care about the weather. You just are playing this game. So paste that image on. It's a really simple way to do that inside Unity. And let's start talking about these assets. We added an asset or 2 of our own for textures. We can import new assets, import packages. Unity comes with a bunch of assets itself. So, first ones we'll look at, skyboxes. Brings up this huge menu. Which skyboxes do you want? Unity already loads things. It's like if you're in Java or Python, you say import math, import random. You don't have those all the time with you in your language, but they're there in the package. You can bring them in. So if you want a skybox, go ahead and bring them in. I'm going to load them all. You probably don't want to do this because it makes your files really huge. But let's go look at some of them. We now have standard assets, skyboxes, lots of different types of skyboxes. Dawn Dusk, Eerie Skybox, Moonshine Skybox, and the Skybox object has those 6 images somehow unrolled from that cube to be in the right places. all they are textures. We saw that they're basically materials with a texture on them. So we can go